Hello students, welcome to MK Study. In this video I am going to explain a problem of chapter Refraction of Light at Plane Surfaces. So here is the question. A light ray is incident on air-liquid interface at 45 degree and is refracted at 30 degree. What is the refractive index of the liquid? For what angle of incidence will the angle between a reflected ray and a refracted ray be 90 degree? Here the question is divided into two parts. So the first part, here we are going to find the refractive index of the liquid, that is water. Let us consider the water liquid. So let us solve the problem. So before doing the solution, first of all you have to understand the ray diagram. Now we are considering a ray, a horizontal line. That horizontal line we are considering it is considering it as an interface. This interface separates the two media. The above of this line we are taking it as a air medium, and below this surface, below that line we are considering as water medium. And if you draw a perpendicular line to that surface, that line we are calling it as normal. Now if you take a incident ray, when the light is incident, that ray we are calling it as incident ray, and the angle made between the incident ray and normal is angle of incidence, that he has given 45 degree. After incidenting the ray, you can see the light is refracted into the another medium. That ray we are calling it as a refracted ray, and the angle made between the refracted ray and normal is 30 degree according to the question. So let us consider the case 1. So given the condition is angle of incidence, let us consider I is 45 degree has given, and angle of refraction is 30 degree. We know from the Snell's law, refractive index is equal to sin I by sin R. So we substitute the values of I and R, we will get sin 45 by sin 30 degree. So we know the trigonometric ratio, sin 45 is 1 by root 2 and sin 30 is 1 by 2. So when you solve it, you will get 2 by root 2, and 2 can be written as root 2 into root 2. So root 2 gets cancelled, so there we will get the root 2, and we know the value of root 2 is 1.414. So 1.414 is the refractive index of liquid medium. Thank you. Let us see case 2. So once again, if you go through the question, already the case 1 we discussed. In the case 1 we have find out the refractive index of liquid medium, and in the case 2 we are going to find the angle of incidence. If you see the angle he has given between reflected and refracted is 90 degree. So once again, let us consider the horizontal line. Above that line is considered as air medium, below that horizontal line is liquid medium, and that line we are taking it as a air liquid interface. If you draw a perpendicular line, so that perpendicular line act as a normal. So when the a light ray is incident on air liquid interface, and it makes the angle of incidence I, and the light refracts on the liquid interface into the another medium, that is liquid medium, with the angle R, and you can see that it reflected ray, and it is making the angle equal to the angle of incidence. So that's why we are considering I is equal to I. So both the angles are equal here according to the first law of reflection. Now let us solve the solution. So according to the question, this is the case 2. According to the question, he has given that angle between reflected ray and refracted ray, that angle. So you can see that this angle we are calling it as 90 degree. So that can be written as a given condition, the angle between reflected ray and refracted ray is 90 degree. Now from the figure, if you see the angle from the arrow marks which you can see in the figure, so that angle is equal to 180 degree. So actually what you call that angle is a linear angle, we call it as. So if you add all that angle, I plus 90 plus R equal to 180 degree, from that equation you will get I plus R equal to 90 degree and R equal to 90 minus I. Now if you see, according to the Snell's law, from Snell's law, we have the formula N is equal to sin I by sin R. Now substitute the values of R that we got, R equal to 90 minus I, we will get N equal to sin I by sin 90 minus I. So that is R equal value. So we know that Sin 90 minus I. It means in mathematics, sin 90 minus theta equal to cos theta. So in place of that we have written cos I. So sin by cos is equal to n equal to tan theta, and n value from the case 1 we have solved 1.414 is equal to tan I, and 1.41 value is equal to tan 54.7 degree, and tan I as it is we are writing here, tan gets cancelled, so I value will go to 54.7 degree.